Greetings and welcome to Dr. Lisa's Quick and Dirty Guide to the T-Test. Now, it needs to be quick because I'm recording this on Screencast-O-Matic and it only records 15 minutes, so hopefully I won't run out of time. It's dirty only in that I'm leaving a lot of stuff out. If you're planning to go into research, I would highly recommend that you take a standalone statistics course. And I recommend that you take it as an undergraduate because I can pretty much guarantee that if you go into grad school, you'll be taking a graduate level statistics and you want to have a good basis to build upon when you take that class. So what I'm doing here is I'm just going over this really quick. Okay, it's quick and dirty. So I am going to start out with some terminology. Some of this is chapter 7. And some of it actually comes from descriptive statistics. If you haven't taken the non-experimental statistics class, and you also haven't had any other kind of statistics, some of this is likely going to be completely novel. I would highly suggest that you go back and you look at that in your textbook if you're really confused. But the other thing I mean by quick and dirty is I'm basically going to give this to you like a cookbook. I'm not going to require necessarily... Well, your book will require that you understand some of these things, but what I'm going to show you in these videos is just how to do it, because I know that a lot of people, when they see, equations, tend to freeze up. And so I'm not really going to go over a whole lot of 7, but I'm going to go over a little bit. First of all, we have a hypothesis. Hypothesis is a testable prediction. And by the way, the lovely thing about video is that you can stop this and rewind it and pause it and write things down at any time. So I'm going to go at a pretty good clip. The null hypothesis says that there is no difference. There's no relationship. These things are completely independent. One doesn't have much to do with the other. And when you think about what I've been asking you to do with the independent and dependent variable, the dependent variable is supposed to depend on the independent. The null hypothesis says, no, it doesn't. It says that the only reason that there was a change is chance. Had nothing to do with the independent variable. It was just chance. Now, when we talk about something being an extreme score in statistics, we mean that it's highly unlikely to be due to chance. It's so extreme, it's so bizarre, that the likelihood that it's due to chance is very, very small. And therefore we say that there is a significant difference between those two things. There's a significant difference between this one mean and that mean for those two different samples. There's a significant difference between your sample and the population because it's so bizarre that the odds of it occurring by chance are very, very low. So that's what they mean when they talk about a significant difference. They're talking about statistics. They're talking about math. And that's what we're going to be talking about here. The other thing that's going to be thrown at you is a lot of letters, both English alphabet letters and Greek letters. So here is your quick and dirty guide to these letters. That weird looking U thing with the odd tail is called mu, M-U. It's a Greek letter. And what it means is the average or the mean of a population. Hopefully you know what an average is. Simply that they teach you that in high school math, if not before. If you don't know what an average is, you really need to go back and look more. So it's the average of a population. The population is, say, the entire country. The entire United States. We talk about the population of the United States, 330-some million. Okay? So this would be the average of all those 330-some million people's scores, for instance. Now, the thing is, it's very, very difficult to get scores from the entire population. You have to conduct what's called a census. And indeed, the United States just finished conducting a census, where they counted everybody and got data and stuff. And trust me, as soon as that data is released, the numbers will be crunched as we speak. So normally what psychologists do, instead of basically testing everybody, is they simply test a sample of the population. They pull out a sample. Now, hopefully it's a representative sample, which means it represents the population. We'll learn a lot more about this as we go. But the wonderful thing about psychology is we tend to name things exactly what they are. And a representative sample is a sample that is representative of the population. What do we call that? Well, we don't call it mu because it's from a sample. We call it X bar. That's called X bar. Now, statisticians also talk about something called the standard deviation. You may have heard of this. The standard deviation is how much that particular, those particular scores of that population. Notice that. That's called a sigma. That's the O with the horizontal tail as opposed to the U with the vertical one. That's a sigma. And it is the standard deviation of a population. So how do the population scores vary around the mean? And generally, it's going to be a bell-shaped curve. You may have heard of that as well, that most of them are clumped there in the middle, and as you get out toward the ends, it becomes more and more rare. Exactly. We have the same thing for a sample, except that we can't use sigma because, of course, it's a sample. It's not the entire population, so we call that S. S is the standard deviation. It's a number that represents how these numbers vary around the mean. Z works with populations, okay? And Z is the distance from the mean in standard deviations. We use a standard deviation as basically the same way that you would use inches or feet or centimeters or meters to measure length. It's a standard measure of length. And a standard deviation is that same sort of standard. And again, you may want to go back and look probably at Chapter 7 a little bit more. It just basically, 99% of scores are within 3 standard deviations of the mean. Now, how big the standard deviation is, if the standard deviation is 1, you're going to have a very tall, narrow bell curve. If the standard deviation is 55, it's going to be a lot further. Because if the standard deviation is 1, then 99% of the scores will be between +3 and -3. Of that mean. If the standard deviation is 55, then it's going to be between +165 and -165. Much broader. We use this, as I said, for populations. We use it when we know sigma, when we know the population standard deviation. If we don't know the population standard deviation, what do we use? We use T. And since 99% of the time we do not know the population mean, we almost always are going to use T. Now, Z is very often taught in descriptive statistics because in a lot of ways it is indeed descriptive. It can also be used to be inferential, which is the type of statistics we're doing here. But we're pretty much just going to stick with it more or less in terms of, t-tests and for a sample. A hypothesis test is, again, just what it sounds like. You're testing a hypothesis. We're using statistics to test a hypothesis that has something to do with, a parameter basically means a number that describes the population. Okay, a parameter is a number that describes something. So we can have a population parameter. We can also have a sample parameter where we're going to compare it to the what might be going on in the population. I'll get to that in a minute. That's probably confusing. For instance, here we go. Manufacturer advertises its new hybrid car. It has a mean gas mileage of 50 miles per gallon. Okay, so all the cars in this population have a mean gas mileage of 50 miles per gallon. Right. You think that it's not. You think they're lying. You think it might be more. You think it might be less. Probably less. And so therefore you're going to test it because you're like, no, this is not what it is. So that would be testing a hypothesis. So how exactly would you test your hypothesis? Well, what you would do is, in that case, you would probably use a z-test, but we're going to pretend that it's a sample and not a population. So what I'm going to talk about here is the t-test. And actually, remember I said I only have a limited amount of time? I only have 5 minutes left, and I'm not entirely sure that I can go through the entire t-test in 5 minutes. So I'm actually going to end this video now, and then I will record a second video with the actual math in it. So I will see you in a bit.